Anybody? The domain of a polynomial function?
Infinite?
Yes, meaning any real number. The domain is x such that, having the property that x is any real number. Okay? That's for polynomial functions. They're very friendly. Very friendly. Oh. Give the domain of this function. Very important. G of x, 4x minus 7 over 4x plus 1. So let's make a little list of functions that we looked at so far. We looked at f of x equals x squared. We looked at f of x equals the absolute value of x. They both are very friendly, defined everywhere. Now we are looking at something else. This is one of the complicated functions. This is not a trivial function. These are easy, but this is not. This is called, of course, a rational function. Remember when we started module 7, we looked at something like this. Rational expressions. Oh, this is a rational function. In order to find the domain of a rational function, I have to state that the denominator is not 0. I move on and divide by 4. So x cannot equal negative 1/4. But this is not what they are asking us to do. They're asking us to find the domain, what x can be. But I have to find what x cannot be first in order to identify what it can be. And in plain English, what x can be? Anything but. How do we write anything but x equals negative 1/4? How do I write that? This is the domain. The only value that I cannot evaluate this function for is negative 1/4. If you ask me to evaluate it for anything else, I'll give you a number back. But if you say, now evaluate it at negative 1/4, I'll say, sorry, I can't. But the domain then is anything but. How do we write that? So let me explain it on the real line first, so you understand what's going on. Negative 1/4 is negative 0.25. So it's this point here. So I have to use this interval, and I have to use this interval. So then the domain will be negative infinity. So this is negative 1/4. Negative 1/4 with a parenthesis. There is a symbol that we have to use in between. It's the uppercase U. It denotes union. Union. The other side, negative 1/4, infinity. Notice that by the fact that I did not have the bracket anywhere, it means that negative 1/4 is excluded. So how do we write in mathematical terms anything but negative 1/4? Is this way. Everything to the left of negative 1/4 and everything to the right of negative 1/4, but not negative 1/4. If I make the error of putting a bracket anywhere, either here or here, then I messed up the answer. Negative 1/4 cannot be included.
Is that just because it gets close to that negative 1/4, but not exactly negative 1/4?
Yes, exactly.
Okay.
It can.
And I get the one.
Say it again.
I get the negative 1/4 just simply by simplifying.
4x plus 1 cannot equal 0. I move 1 to the other side, it becomes negative 1, and I divide by 4.
Whatever that answer is the answer is the one that cannot be.
Yes, this is what x cannot be. But the question is not what x cannot be. The question is find the domain, which means what x can be. And that's the reason why I have to write this. Now, if they're asking us to write the set builder notation, this is slightly easier. I will write x with the property that x is not negative 1/4. But this means nothing. This is the important type of answer. So now let's see what they want. Okay, so that's what they want. But this is not what we are going to need moving forward. We're going to need the interval notation.
Can you
Okay.
do another rational function like that?
Oh, yeah.
Thank you.
Yeah, let's see what they give us. If not, I'll make one up. Okay. So let's take a look. Here's another example. F of x equals 2x minus 1 over x minus 4. We know that x minus 4 cannot equal 0, which means x cannot equal 4. In interval notation, negative infinity to 4, union 4 to infinity. Or in set builder notation, which is not useful, we're just copying the condition. Any questions? Okay, so let's look at a table now. Okay, so it says use the table below to find the indicated values. Can anyone tell us how much is h of negative 8?
8.
It is 8. Good. Moving on. Can anyone give us f of 4?
4.
4. When x is 4, y is 4. Good. For what values of x, now this is a very important question, is h of x 8?
8.
So when I look, careful, I look at age of x.
2.
Exactly. So I have to write them, use a comma to separate answers as needed. So I have to write negative 8,
Okay.
comma 8.
Okay.
Good. I want to talk about something else and then we'll go back. Let's suppose, this is very, very, very important to understand. Let's suppose I have this graph. This is a function by the vertical line test. And I'm going to put some numbers here. One, two, three, four, five, six, seven. 1, 2, 3, 4. Okay. And negative 1. I'm going to ask several questions here. Can anyone identify the x-intercepts as ordered pairs?
Negative 1, 0, and 3, 0, and 6, 0.
Can anyone identify the y-intercept?
0, 2.
0, 2. Perfect. Now I have the following question. Find f of 7. Here's how I think about it. Obviously, I'm told that x is 7. Well, x equals 7 is a vertical line. I graph it or just imagine that I graph it. It crosses the graph in one point, so I will have to read the y value. Can anyone read the y value from this graph when x is 7?
So 4.
So we read from the point 7, 4. Perfect. Any questions on this? Now here's the second type of question, which is totally different. Find x such that f of x equals -1. This is a totally different situation because this is y equals -1. Y is given now, not x. So I have to draw, or imagine I draw, a line y equals -1. It meets the graph somewhere, and I have to read the corresponding x value.
4.5.
4.5. So I read from the graph, from the point 4.5, -1. So f of 4.5 is -1. Exactly. So let's analyze this because this is super important. When I'm asked to find f of 7, I am given x. But when I'm asked find x such that f of x is -1, I am given y. I know, like ages ago, we learned that x equals 7 is a vertical line and y equals -1 is a horizontal line. Therefore, I graph them, or just imagine that I graph them on, because I can't graph them on the everywhere. I can here. And I respond, I answer the question. So here, this point is 4.5, -1. This point is 7, 4. So careful, you have to look at carefully at what you are given and what you are asked to find. If I'm asked to find f of 7, I'm given x, I'm asked to find the corresponding y. If I'm given f of x equals -1, I'm given y, and I'm asked to find the corresponding x value. Good. We just did a problem like that. Yes. Good. Match the adjacent graph to the function listed whose graph most resembles the one given. Choose the answer below that most resembles the given graph. So let's take a look. We haven't even talked about the cube function, so we don't even know what that is. So it makes no sense. The square function, which is x squared, we know the shape, it's absolutely no connection. The identity function I did not mention, but this is important to mention now. This is, and we can add it to this list. Where is my page with the list? Was it that long ago? My goodness. I'm not lazy today. I have no idea where it is. The identity function is important. Is the simplest possible linear function. I don't know what I did with that. I hope anyway, so I'm going to write them again here. So f of x is x squared. f of x equals the absolute value of x, and rational. The simplest possible rational function is just 1 over x, and the identity function is the simplest linear function, and of course is this. This is called the identity, y equals x. Identical. X and y are identical. That's the identity function. Okay, so this is quadratic, absolute value, the simplest rational, which is, we're not going to graph it in this class. It's one of the most sophisticated graphs. And the identity, which is very simple, the linear function. Good. So obviously, the last three make no sense. The square function, we know how it looks like. The cube function means x to the third. Identity function is f of x equals x. The absolute value function, no, we know it's a v function. The linear function is true, but this is the constant function. So linear, that's correct, it's a line, but it's a constant. It's y equals -6. So we will choose the constant function. But linear function is also correct. The absolute value, no, it's a v function. Quadratic, no, it holds water, it's like a cup. A cube function, we don't even know what that is. And the identity, it's a straight line, but it's a line that bisects the first and the third. So the constant function is, but linear is also correct. This is the identity function. This is how it looks like. So it bisects. So the identity function, it's a very important function, is this. It bisects the first and the third. This is y equals x. So we learned a lot, way more than we really needed. But they are basic functions. We know how to graph this. We know how to graph this. This we don't know. It will take a while to get to that. This we know. So yes, this is the identity function. No discussion. Yes?
Is a constant function always just a vertical or a horizontal line?
The vertical is not a function
Okay.
by the vertical line test. So the constant
Right.
function is only y equals, yes. Or f of x equals 5 or 2 or 3, yes.
So it'll always be just a horizontal line.
Yes,
Okay.
it's constant. There is nothing else. For any value, it's the same. For any value of x. Sketch the graph of the following function. So here's your example. Y equals -1. Is it a v function? No. Is it quadratic? No. This is the cubic function. No. We know now, we identify, we did not talk about the cubic function. But they make no sense. This is y equals -1. So it must be the constant function right here, a horizontal line at -1. Any questions? So we learned a lot so far, these two sections. How to graph, how to identify these functions, very important. Let me also add, if you want here, the constant function. F of x equals a constant, c. Okay, so this is a horizontal line. Horizontal line. Good. So we actually finished Mod 7. So we did 2 sections last time and 2 sections today. You're not responsible for anything in Mod 8, but I just want to show you a couple of things because we have a few more minutes, 5 minutes, and then I'll stop, I promise. And you're not responsible for anything in Mod 8 just now. Next week. After this week, we're down to 3 weeks before the final exam. And we have to review for test 4 and we have to review for the final. So in Mod 8, we talked about square roots. This is a new function for you. X squared, the absolute value of x, 1 over x, which we do not know the graph. It's a more sophisticated function, the identity function, and the constant function. So we're going to talk about the square roots. But before that, I just want to give you the heads up. Meaning, if I have the square root of x, this is the same thing with x, power is 1, we don't write it. Index is 2, we don't write it. So a square root, the square root of x is the same thing with x to 1/2. Do you remember when we said, what does x to -3 mean? Oh, it's 1 over x to the 3rd. It's another way, a condensed way of writing this fraction. The same thing here. We have 2 different ways of presenting the same thing, like this. X to -3 is 1 over x to the 3rd. So every time we take the square root, we know the index. This is called the index. This is the square root symbol. Square root symbol. And this is called the radicand. So the square root of x is x to 1/2. Now, there is a problem with the square root. The square root is not friendly, like polynomials, like the absolute value. I don't have to worry about domain. I do have to worry about the domain. So here's the problem. The square root of x requires that x is positive or 0. I cannot take the square root from -9. It's not a real number. I can take negative the square root of 9. Yes, I can, because it's by the order of operations. The square root of 9 is 3 with minus in front. This is -3. But this is a function with restrictions, like the rational function. It's a problem. This does not exist when x is 0. The same thing here. This does not exist if x is a negative number. So careful with this. Of course, we may have any other index, but it has to be a natural number from 2 and above. So if I have, let's say, the cube root of x, cube root of x, this is x to 1/3, and so on and so forth. When I have an odd index, domain, all real numbers. Friendly, very nice, very nice. But if I have an even index, domain 0 to infinity. So odd index behaves like a polynomial. It's not a polynomial. What I'm saying is I don't have to worry about domain ever. But as long as the index is even, this quantity must be 0 or above. Here it doesn't matter. Positive or negative or 0, everything goes.